Welcome back to the N4 Learning Channel. We're doing a project for an art gallery, and we're doing running or controlling 6 CRAC units. I'll just bring across the panel drawings first, which is what I'm being given to work with, as well as the DesOps. So we've got the 24 volts supply there coming in, and a socket for the panel, and then we've got the building fire alarm and a reception common alarm panel, which we're going to send a signal to if there is a common alarm. We've got a fresh air damper, CRAC unit enabled, and open storage area CRAC number 1. There's 6 of them. It's electric heater, and follow it through. So that's another unit, 2, 3, 4, 5, and I presume that's 6. Yes, it is 6. These strap fans, 3 off. General extract, ventilation extract fan. Leak detection, fault. Drainage pump fault, leak detection active. We've got a switch in there, which we're backnetting to the 6 CRAC units. We've got a display on there. We've got the MAC 36 controller, a Mix 38, and a 120, which is just 12 digital outputs with switches. ISMA, so all these are ISMA products. And then these are the inputs and outputs for the unit. So what I have done, and just move that out of the way, I've got DesOps as well there. So I've already started it, but I'll show you what I've done at the moment. So with a blank station, meaning it's not connected to anything, it's not live or anything like that, it's just written on my computer. And we've got the ISMA network for the MAC 36 controller. So all I've done there is put the points in there. Now with the CRAC units, we've got a parts per million sensor, ppm, for each CRAC unit. All I've done there is where I've got the input for it, in this case universal input 2 there, going into there, 0 to 10 volts, 0 to 1000 out. Now the reason I've done that instead of changing the point, because I could have just adjusted this point, and what I would do is I can just adjust the scale to go 0 to 1000. But the reason I've done it like that is the unit is a Sante unit, and you can adjust via switches inside your parts per million. I think you can have 1000, then you can have also 1600, could be wrong, and there's another setting. So I've done that, so all I need to do is change that output high limit there. I presume it would probably be better to just put a Boolean writable in there, change ppm scale, not a Boolean writable, numeric, change ppm scale, actions set to 1000, pin slots, get rid of in 10, so you know nothing's going into it, it's actually a setting. Put that to 1000. It'll only be used for the engineer. Let's just make it neat and tidy. So put that to a 0 so there's no decimal place, and then we'll select concentration and we'll select ppm. Save that. I think while we're in there, we'll right click, reviews, we'll do the AX slot sheet, we highlight emergency and auto. I press my shift key and then click there, and then config flags, and we'll hide them so you can only see the set. And then we can move that to that 1000 there, and then all I need to do when I'm on site commissioning is, depending on what it's set at, I can just change that and they'll all work the same. Anyway, I digress. We've got Modbus COM1. That is going to be for the ISMA modules. So a mix 38 and a 120. I'll open up the wire sheet. So there's your mix 38. I've added these. You normally don't see me add these in there, and I've set them all to true, so that if we do lose communication, digital output 1 to digital output 8 will all go true, and that they're basically the enables for the CRAC unit. So if we did lose comms, then they will be all switched on. Though I wasn't bothered about I think one of these is the fan. No, these are all three. The fan's on the other one, extract fan. And then if we look at the 120, it's just 12DO wire sheet. I've put them all into default true. Digital output 1 to DO6. We lost communication. And then BACnet, I've done nothing with BACnet because I'm not on site, so I can't discover the units, and it's been a while since I've done a CRAC unit before. So they're all my inputs for the CRAC units, and for all what's on the panel drawings. They're all my outputs, and that's my logic that I've done at the moment. So I've done fresh air damper logic with the parts per million, but I couldn't find in the DesOps anything about the fresh air, so that's why I don't have anything at the moment. I've done digital and I've done a numeric output because it's not in the DesOps and I can't see it on drawings. So maybe I've written that and it's no longer needed, but I'm still leaving it there for when I go to site and commission, just in case someone says, oh, we forgot to put this on the DesOps and the drawings. Distract fans are on the drawings. As you can see, I put a little note there, and I put the DesOps in the description in the notes, so I know I need to write this to meet the description of operation, which I have done. I'm just looking at my fire alarm there, not using high level. I'm just looking at this now. So we haven't, it says here the 3 points held, BMF fascia, different set point from is adjustable with predefined high and low limits. The set point and limits for all this will be required in order to do, the enabling for fans will inhibit. Okay, that's your fire alarm, which is here at the end. I'm just trying to see which sensor we're using. It's installed a high and low temperature sensor into the BMS control panel, and on a significant rise in the high level temperature relative to the low level temperature, an enable signal will be sent to the zone controller. So relative to the low temperature sensor, I'm not too sure. What I'm going to do here is, these are my control variables which I haven't yet put in. So I'm going to put in a maximum block. Logic, maths, maximum. Temp Z1. Views AX slot sheet. High, low. High level, low level. High and low in there for Z1. Duplicate that. Automatically it puts a Z2 for me. High and low. And duplicate that. And it automatically puts a Z3. Now if I just decide that they're going to just use one sensor, then I can delete one, or I can even write software to say use both sensors, or just use high sensor or low sensor, and I would select the sensors, but I'm leaving it like that at the moment. Zone 2, that's going to go to zone 1. That one's going to go to zone 2, and this one's going to go to 3. And we have different set points there, a high and a low, so it's working between 18 and 28, so it gets to 28 it will start, 18 it will stop. And all I've done there with the block is a high and a low. They're both blocks are set up exactly the same, so we've got the reverse there and we've got direct there, so that's the only difference. And then this one is going to a NOT gate, and then they're both going to an AND gate. So let's just prove that one working. So it's 28 and 18, zone 3. So if I override that, emergency override, and put that to 30 for example, 30 is in there, 30 is in there, oh there's a 10, it's parts per million, sorry, and no it's not, yes it is, no, so 30 degrees there, into there, but I've got a big differential there of 10, I don't want that. I never copied across these. So now that's true, true, that's false, and through a NOT gate, true, and the fire alarm's not on, not healthy, true, enabled. And then if I turn that off and put that at 16 degrees, that goes off. There's actually that one there is 0.5, so I could have put in emergency override. I could have put in 18.6 and it would turn on. He says 18, and that hasn't turned on. 18.7. 19. Oh, set points 28. What an idiot. Actions, emergency override, 28.5. Turned on. Actions, emergency override, 17.5. Turned off. emergency auto. They're probably, I mean, I've commissioned these. I honestly think they're going to be around about 22 and probably 18. It's certainly not going to be 28. In fact, I'll set that now. 22, 22, 22. They don't give a setting in the DesOps. They say adjustable within predefined highlight. The set point and limits for this will be required in order for to set up naturally. But they don't give these set points in the DesOps. I'll bring across the DesOps. Just basically telling you what equipment's being installed, and then these are the DesOps that I'm copying and pasting across into my wire sheet. I highlighted that. That was one of the other wire sheets I've just done. I've still got this bit of the DesOps to do. Supply and extract, leak avoidance, isolation valves and anti-Legionella flushing. So let's just take that out of emergency auto, put it back to normal. So I've still got the supply and extract fan leak avoid. That was a general alarm. All it is going to go to the reception. So all the alarms that goes to reception, that one wants a NOT gate in there. So let's put a NOT gate in there to reverse the alarm, because that's a fail-safe fire alarm. Put that in there. I'll put that in there. Alarm to reception. Rename. Rev fire, reverse fire. Right. So now supply and extract fan. A newly installed extract fan, monitored. Fan inverter is enabled via fault-free contact at the BMS and monitors the fault condition from the inverter via the. So we know straight away we've got a output for the fan, and all I'm going to do is quickly go to an output that I've done before. Copy that. I'm going to take the fire because I know it's going to be a fire, and I know it's going to have an enable, which I don't have an enable on this one. So, and I know it's got also having a fault. So let me just paste that into there. So there's my fire alarm. Rename, enable, extract system, extract fan, enable extract fan. And it mentioned that we've got a fault. So if I go to my inputs and look for my fault for that, general vent extract fault, I'll just copy that, paste that into there, take out the, I need to take out any alarms that's on here because I don't want the alarms twice, and I don't want the history. So let's just delete the alarms and delete the history. So that's that one done. And then we need an enable. So we've got the fault, we've got the fire alarm. Will be coming into this folder. So differential pressure switch to find the flow proving. So let's go and get these differential pressure switch, supply and extract pressure. Copy, paste, rename, take out that. rename, take out that. I'll just open up the folder down here, open up this down here, remove the numeric history, remove from numeric history because you don't want it twice. And I also noticed, which I don't know if it's mentioned there, but when I did the points, I think I got a speed for that. Outputs, so not inputs, outputs. Yeah, I have. Copy, paste, take that out of there, take out the numeric. So that's the speed. Just move all these over here. I don't know how big it's going to be, but it shouldn't be that big, the logic. I'm just looking down now on the left hand side on all my points that I've put in. Extract fan low, that's another input. Copy, move on alarm, paste. And let's have a look what's inside there. Yeah. Delete the alarm, delete the history. I think all that does is put a light on the panel, but we'll bring it into the logic, into the block for the extract fan. None of them. And that is it for all the inputs and outputs, I believe. I can't see another. No, I can't see anything else. So let's compensate these points across. I always like to open up the folder on the left so I can see the points I've done, which are all there in this. I'm going to right click that, go to composite. So I'm going to put my fire alarm at the top. Well, I'll tell you what, I'll do it the same order as this so I know what's what, and then I can re-change it later. So that's going to be an output. That's going to be an input. That's going to be an input. That's going to be an input. That's going to be also an input. That's going to be an output. Now that one, extract fan low, I think it's well, it's definitely an input, isn't it? Yes, it is. It's definitely an input. Right, so move that out, down one. Move that down. So enable extract fan and extract fan speed. Leave the others where they are. Now I've got to give them a title now, because if you look at what it's done, there's no wording there. So we need to do the wording. Views, AX slot sheet. But we know these out is enable extract fan. And we know because of the percent there, that's speed. Extract fan speed. Now we know some of these because we can read the text, but I also know because I've got that here. So fire alarm, general extract fan. So fire alarm, general, so extract fan fault, supply pressure, that one is extract air pressure, and finally that one is extract fan low. So we have all the points now. In fact, what I'll do is link mark that, and let's just attach the points from the AO that we've got. Supply air pressures 1, link 2, out supply, link 2, out extract, fault, link 2, out fault, fire alarms up there, link 2, out fire alarm, and then we've got some outputs that we need to send. So extract fan low is an output, not an input. So take out that, okay, move that across there, composite it again, extract fan low, out, which is giving it an out too, views, slot sheet, so that's rubbish, delete it. Extract low, link mark that. Now we can put the outputs in there, and I can find it again. Extract fan low, link from, extract low into in10 of the digital output. We've got an enable, link from, enable into the output, and then we've got a speed, link from, fan speed into the analog output. Now we're going to be doing the fan speed 0 to 10. I think I've already changed the point, but I'm just going to check the point for AO1 to make sure, because it normally accepts 0 to 10 and we're doing 0 to 100, so we need to move it across by 1 decimal place. Yeah, I've moved it across. So normally that's at a 1, so 0 to 10, and I'm doing 0 to 100, so it's easier just to move the decimal place and put in a conversion in it. Save. So now all the points are linked up, all the inputs and the outputs here. It's not giving the speed at the moment, so now we've got to write some logic to go in between there. I know I'm going to be needing at least one set point adjust, so I'll just take one, save me from rewriting it, I'll just take me one from some logic that I've already done. Doesn't matter really what it is. It's because this is going to be in pascals. They're in temperatures and they're in parts per million. But let me just take one of these. That's not that one. I want one of these. Copy. Paste that into there. And provide a pressure monitor sensor mounted within the common extract air duct, which was used to register the static pressure of this duct in the system balance state. A corresponding sensor is installed in the supply duct for CRAC Unit 6 and also used to measure the pressure at the balance state. Measures mounted within the common extract air duct, which was used to register static pressure of this duct in a system balance state. A corresponding sensor is stored in the supply and is used to measure pressure at the balance state. It doesn't tell me which one. In general, the extract fan speed will be varied to maintain the determined pressure as set during commissioning relative to the supply air pressure. So that was used to register static pressure of the duct in a balance state. Also used to measure pressure at balance state. Right. Okay. So we'll put that as supply, extract and supply. Extract pressure set point. It's in pascals. Pressure, 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 pressure. I don't want pressure ratio. Pressure. Pascals. I have no idea what it's going to be between. So I'll just put infinity there. Plus infinity. Minus infinity. And we don't want that because I copied it. Let's get rid of the history. I know. Sorry, let's put history back so I know that we've changed it. And duplicate that. Supply. Pressure set point. In general operate. See, it doesn't even mention about the fire alarm here, but you certainly don't want the fire alarm. You don't want it running when there's a fire alarm. So that's something they've missed off the DesOps. The fan inverter is enabled by a fault free contact BMO minus focus from the inverter via. Okay, so we need this one to be true, or the opposite anyway to that at the moment, and that's false. I believe healthy is false. So if it goes true, then there's a problem. So let's not a NOT gate there, but let's put a NOT gate on the fault. Invert fault. So that's now a true. If that was all working, that would be a true. Let's put an AND gate now in here. Safety. Okay. Put that into there and that into there. Views AX slot sheet. Fire. Fault. So we've got that in there. We'll put for the speed, we will use a loop. Fan speed. Pin slots, set point control variable, loop enabled. And we'll do the prop int. And we'll set a 2 in there. We'll set a 1 in there for the moment. And we go save. We've got only one fan speed, so and it's extract fan speed and extract pressure there. So that's my control variable. That's my set point. And we need a minimum speed. So that's maximum and minimum. So maximum can stay as it is, but I'll still expose a point. Pin slot. Maximum, minimum. And we'll put in a minimum speed of 50% is going to be 25 hertz. 20 hertz is normally the minimum, so we'll put 40%, so it can't go below 40% when enabled. Change the output to percent. And I'm not interested in a decimal place. So that's my fan speed. Now I only need that enabled. I don't want to put that directly to there, because I only want that to have a value once we are happy that that is on. Loop enabled. Otherwise, when loop is not enabled, that's still going to give 40% out, i.e. being the minimum. But I don't know how that system works. For all I know that we've got an enable, we could also work on a fan speed. Sometimes people write logic and says, okay, well, we've got a fan speed of 40, we will run the fan. I don't know. I have not been on site or commissioned it. So because I don't know, I am going to make sure that when we haven't got a signal, that we are at a 0. So I want a numeric switch, numeric switch, enable speed. So we put that into the true. False we leave it 0, and we take that true and put it into the switch there, and then I'll put that into the speed. Now it doesn't tell me how it wants me to give the extract fan low, but I would say if it's enabled and we've not met the set point within, say, 5 minutes, we put that on. We're there to maintain the pressure at determine pressure at the set of commission relative to the supply air pressure. Speed will be there to maintain the determined pressure as set during commission relative to the supply air pressure. So let's take that out, put that in there, take that out, put that in there, take that, put that there, and then we still got our extract. supply. Just for the hell of it, I am also going to do an extract. Put a 1 at the end, so all I'm going to do is take that 1 out and put a small s. Just change the text slightly. Put that into there, put that into there, put that into there. But I'm not going to do anything with it. I'm just going to leave it there in case I need it for future. We need to enable the fan. So long as the fire alarm and there's no fault, we can run the fan. And the fan will only run when the supply air pressure is above 800. It will run faster. Otherwise it will just run at 40 hertz. 40%, 20 hertz. But as the supply air pressure increases, that's going to be the wrong way around, isn't it? Yeah, of course it is. So we need, if I put that to 900, as the supply air increases, we need faster speed. The pressure increases, which is the right way around. It's going faster there. Too fast, but it's the right way around. Let me just put that 2 into there. And then we put that 1 into there, because we'll use exactly the same as what those settings are. So if I change that, that will automatically change, even though we're not using it. So we've gone over and supply fin speed, but what we need to do is 0.1, make it a bit slower. So more pressure, faster speed, less pressure, minimum speed. Emergency auto, minimum speed. If we want to reverse it, all we do is change that direct to a reverse. We'll test that when we're on site. But we need to do the alarm now. So we will go for, we need to be enabled, and then we need that to be close to that, or greater than, or less than, depending on, yeah, so we need that one to be as close as we can to get with a differential. So let's make it dead on at the moment, 800, and we'll use a T-stat. Perm slots, diff, supply, doesn't matter which one we put in really, PA. Take out that, false, and we'll do a differential of 10 is fine either way, 20, we're in hundreds here, so if I do 100 that's 50 either way. The save. I think I was right with direct anyway. Yeah, direct, save. So put that to actions, emergency override, 900. So that's 850, and that's true. actions, emergency override 700, that's false. So that's alarming because we're lower than what the set point is. Sorry, that's not alarming. So let's reverse that. So we've got a true. And then actions, emergency override. This isn't going to work properly, by the way. I've just realised why. The set point there, because we've got 100, we need that set point to be half of that 50. So what I'm going to just do is divide that 100 by 2. So it automatically calculates it, rather than me putting a figure in. Divide that 100 by 2. Because I want to get plus or minus from the set point. So that's 850 and 750. Well, the set point's 800. So I need to add whatever the differential is of 50. I need to add it onto there, I believe. So the set point is still 800 plus 50 is 850. Let's see how this works. So actions, emergency override, we're at set point 800, so at 40%. Actions, emergency override 850, we are at 100%, so it's trying its best to keep up. Actions, emergency override 860, so that's 850 plus, so that's going to be, that's wrong. So I've got to take away 50, not add 50. Delete, subtract, pressure, take away. Let's try that again now. Actions, emergency override, let's put it to something stupid like 900. That's false. Actions, emergency override, put it to 700, so it's low now. We're increasing the speed. 700, and so that's 700, so control variable, oops, what's that one there, is 700 and 80. So why isn't my speed increasing? Because we've got low PA, our set point's 800, so let's reverse that. So our speed starts to climb up, so that's now to 100. Actions, emergency override, so we get to a balanced, that's dropping down, that's still false. Actions, emergency override, we go 900, we're at speed, and that's still false, and anything after that 1000, yeah, that's all okay. And then but we go below set point, actions, we put it to 800 first, which is set point, so nothing should happen on the T-stat. Speed's gone down. Actions, emergency override. 750. Speed's gone back up again. That's still not in alarm. Actions, emergency override. It's 750 there. So if I go to 700 now, it should go alarm because it's too low. And then I want to wait. Timer, Boolean. Wait 5 mins. In. I presume we probably need that delay adjustable. On delay. Take out that. Duplicate that. Alarm, low, alarm, on, delay. We're in seconds. Time, seconds. We're set at no more than 120, and we still want a delay no matter what, so we'll set it no less than 30, so they can adjust it between 30 and 120. We need the numeric history in there. Actions set 30. Now I can't put that straight into there because this works in milliseconds. So if you see, if I put that straight into there, 30 milliseconds. So that's no good to me, 30 milliseconds. So I want a multiply. It's in maths. I don't know why I'm going all the way up there. So that should be, if I times that by 1,000, that should put me to 3. So if I put that into there, that's only 3 seconds now. Sorry, 30 seconds. 30 seconds. No, that's right. So rename MS to sec, and that is rename extract low check, rename diff divided by 2, it's okay, I just realised that's completely wrong. Is it 2, 2, so that's 50, which is 50 PA. Save. And that is PA. And that is new set point. That's the existing set point. Take away 50. So we're at 40, we're at supply air pressure 700. That's wrong, isn't it? Because the set point's 80. I should be, oh, I'm seeing it increase. I'm looking at the wrong one. Maybe I shouldn't have bloody put that in there. It's throwing me off. 100, so we are right. And then we increase our set point to 900. We've backed off to the minimum of 40. And naturally we haven't got any alarm on because we've met our set point. Emergency override. We go to 750, so we're 50 below our set point, and we're still at 100. No alarm. Actions. Emergency override. 749. So 750, take away that. So it's got to be below 700. So it's got to be below 700 for that to kick in. Actions, emergency override. 699, that should kick in, which it does. So the pressure's got to be I'm just wondering why I'm changed the set point there, because 750 control variable is there. The 800 take away 50 is 750, because I'm dividing that by 2. If I want to make it any finer, I divide it by 4. So let's change that 2 to a 4. But this is only for the alarm. So that's now 25. So that's, I don't think I want to, I want them to be a problem for an alarm. So I'm going to leave it at 2. But I can't send that alarm until I know that everything is running. So we've got to take that output out, and we're going to have to put an AND gate in there. Run, then alarm. So we've got to be enabled. Low. Views AX slot sheet. Enable. Low air alarm. Well, it's low extract, isn't it? EXT alarm. Then we can put that into there. And then once that's done, we can put that into there. I presume there's an alarm attached to this. There will be on the other. Let's just check. Follow it through. Follow it through to the point. Did I put an alarm on that? I certainly did, and a change of value. And that's gone into alarm now. Low alarm. And then we need to enable so we're doing the speed, but we need to enable that, and we want to be enabling it from this supply fan speed, just in case. No, because 40 is going to be on. So regardless of the speed, the fan's always going to be running at minimum at 40, and it's going to be increasing speed. So it's only the fire alarm that actually turns the fan off, which I never mentioned in the des ops here. Provide the flow proving. Oh, which is mounted across the fan to provide pressure switch and failure of the flow. Well, I can't see in my inputs, which has got to be an input, a flow switch. I've got that, digital input, extract vent, extract fault, and then I've got an output. Was it an output? I'm sure it was. Yeah, extract fan low. So I've got extract fan low, and I do have general vent extract fault, which is that one there. But I certainly do not have in my IO. So let's go to the drawings. Where are you, drawings? Let's go to extract fan bit. Extract fan, let's just blow this up some more. Extract fan. General ventilation extract fan. Flow fail 19.2. Fault relay 113R. We'll put the fault, so this one we'll put the fault on. So that's my fault, that's my speed, and that's my enable, and that's a flow fail that I will send. But where is my, there's my auto, which is from the BMS energizing 11R1, which also puts that light on. 11R1, which is that for my enable, which is right. But what I can't see here is flow. And they definitely said in the des ops, fan inverters able to develop for you. A differential pressure switch is mounted across the fan to provide the flow, proving any failure or flow will be reported to the BMS. So a differential pressure switch normally is just the on and off, so it's a digital input. Well, there's no digital input. So let's have a look at the IO. No, is there any point in looking at the IO, because I know there's no digital input. General ventilation extract fan speed. Yeah, we know about that. General ventilation extract fan flow lamp. Digital output 2. So I'm putting on DO2. General ventilation extract fan flow lamp. That is going to extract fan low DO2. So that is not really, it's not extract fan low, It's extract fan flow. So I've misread that somehow. Extract fan flow lamp. Right, okay, so that's my fault. Rename that. Flow lamp. There's certainly no alarm tied to that. I could still leave a history, and that's flow, no flow. Save. Extract fan flow lamp. Extract fan. So views, AX slot sheet. Extract fan flow lamp. Lamp. Views. Config facets. Flow, no flow. Go back. Config facets. Rename. Flow lamp. So I will know this flow because of the, so we can take out the alarm there. We enable it, and as long as we, well, I can't say 40 because 40 is the minimum. So I have got to look for the pressure to change. So I'll tell you what I'm going to do. Rename. I could put that to flow check, but what I could also do, I want to monitor change on the on any of these sensors. Because I don't know at the moment. I'm not on site. I don't know what the sensors are reading when the fan isn't running, and I don't know what they're reading when they are running. But what I want to do is I want to prove flow, and the only way to prove flow is looking at what the static pressure is and what the flow pressure is, with the AND gate as well, I presume. I think that's the only way I'm going to. So I'm just going to tidy up this bit here. No, I'll leave it as it is. So extract fan flow. I certainly can't just put that enable to that, because just because we're enabled it doesn't mean there's flow. And the speed, well, we could do it. No, I can't do it from that because that's me sending a speed to it. I have got to do it from that sensor. And I'm going to have to know. I'm going to have to know what the static pressure is first, so that I know that that sensor's working, so I know the fan's working. I mean, I could say if the fan speed is 41, I know it's working, but then eventually I know it's going to drop down to 40 when we've met set point and gone over set point. That would drop down, so I need to know what the static pressure is, and then do a greater than. So let's do a greater than now. Not greater than equal to, just a greater than. Take that into there. Take my main pressure. Let's say the static pressure is I don't know, let's say it's 200 parts per million for the moment. So rename above static pressure, and I presume we do a static pressure. Duplicate static pressure value, set point. Got graphics to do on this as well. 200 actions set to 200, so it can be adjusted by the graphics when I do the graphics. And we're not doing anything with this alarm now, are we? Because we don't have an alarm. Man, you can still give it an alarm. Yeah, why not? We can still send an alarm. We're just not sending it to an output. So let's just make a new Boolean writable and extract fan. Below pressure set point. Now I've put lots of spaces in there. I'm going to take them out and put underscores, because the space gives a %20 in the history. And I will be attaching the history onto here, even though it's still an alarm. And start to get rid of in 16. Put that into there. So we've got an alarm on at the moment. Flow alarm. It's not flow, it's pressure. Pressure healthy. Or is it flow? Because, but it's working on the pressure to determine the flow. And if we don't get the right flow within certain period, then we alarm. Save. And then I want to go and put in an alarm. Extensions. Boolean change of state. And do I need to put in a history, so I know every time it's been happening, or I can trend it? History. Really? You're not that high there. I've got to say, I'm sure I've used histories before. And Boolean change of value. Drop an history into there. That title. Right. that's that one done. I'm going to go and make myself a cup of coffee, because that's the next one I've got to do. So I'm going to put you on pause. Right, now we're going to do this. I've just put these points in here. Anti-Legionella valve north, humidifier feed north, anti-Legionella south, humidifier feed south. And now we want to do the Legionella. The lines of 2 solenoid valves fitted, the same as the top there. This is achieved by operating 24 year beam. The leak avoidance is in solenoid valves is also open during the so lines of a solenoid valve each are opened on a weekly basis for a period of 2 minutes to flush the contents. So let's get a scheduler. We could use a trigger, but I'm just going to use a scheduler. Boolean. And we'll put in that as flush system Legionella. We'll do it on a working day. No, this can be changed, of course. So that's 12 to 12:30. We only want 2 minutes every Sunday morning. So we go into our kit control. I'm going to do a one shot. I'm going to set that one shot for 2 minutes. And it said 2 minutes and I didn't say it's adjustable, so I'm not going to let them adjust it. One shot. So that fires at midnight. Was it midnight? Yeah, next time, midnight. And we want it firing for 2 minutes, that's what they've asked for. We'll expose it anyway for 2 minutes so I can easily see without having to go in there. 2 minutes. Open. Valve. So in this particular one we need to open up the feed as well as that on all of them. So we want it to go into all of these, but I know that this one above, using a backnet point, is only for the humidifier feed. So I need to put an OR gate at least on that one. Because I can then move it to, so let's just take that and that across to there. I put one OR gate. Open water valves. So when that fires, that's going to open up that valve, but then that is also going to open up that valve and that valve, but that's going to open up with a backnet command. So new bootable backnet CRAC. Right, we're going to have, if none of them on, these valves will remain closed until any relevant unit goes into operation. Okay, so I need the enables, and requires a cold water feed to be open. This will be determined from a backnet point transferred from the CRAC, so I'll put the enables in an AND. the backnet point. So backnet, open, valve, CRAC number 1. Pin slots. That's going to be an open or a closed. That's going to be my command from there. Duplicate 2, duplicate 3, 4, duplicate 5, 6. We've got a north and a south, and I don't know what CRAC units are on north and what are on south, and it doesn't tell me. Oh, I've got a map, I think. Let me put you on pause again. So I've got this. Let me bring this across. So these are the CRAC panels. 1, 2, 3, 4, 5 and 6. So depending, I presume that's going to be north, 5, 1 and 2, and 6, 3 and 4 are south. So 5, 1 and 2 I believe is north. Okay. So 5, 1 and 2. I'm going to make a note here. New. Text block. Note. Right in there. CRAC units 1, 2 and 5. 1, 2 and 5 are north. CRAC units 3, 4 and 6. 3, 4 and 6 are south. Don't make it bold. Border and give it a background colour. One, 2 and 5 are north. 1, 2 and 5 are north. And it's up there, so that's north. 3, 4. 3, 4 and 6 are south. Duplicate. Save. Put that up there. Three, 4 and 6. Now, do I need... No, I'm not going to put the enable of a CRAC unit there. Or am I? Because we've not enabled any CRAC units yet. I don't think. If I look at my digital outputs folder, yeah, none of them have been enabled yet. So I don't even know when I enable them yet. There's no points here on the intent, so it's not in the logic. There is for that, there is for that. They're all spare. And we're doing them now. And we're doing them now. And then we haven't to put anything in for them enables. So I don't even know. I presume they're going to be enabled 24/7. So there's no point in me putting an enable, just use the backnet command out to basically, in case it's in hand and I get the information, I don't want to be putting my enable in if I'm not, if they've put it in hand on site. So we're just going to have it for that one for the north. Rename north. Duplicate south. Take that out of there. Put that into there. An OR gate there. North. Pin slots. Put another slot in there. That one. That one. That one. North. South. Views AX slot sheet. I think that's it for that one. Just got to composite these points to the outside. Composite. So those are my outputs first. Put it in order so that I'll be able to see it in a moment. Out to do the text. Out. Out. It's water, so it doesn't make any difference for fire. You don't need to put fire in here. System. And these are my inputs. CRAC 1, 2, 3, 4, 5, 6. I'll put them outputs down. Okay, views, layer sheet, views, AX slot sheet. Bring that down so I can just see them there. That one is anti-Legionella valve north, south, humidifier, feed, valve north, south, backnet, CRAC, backnet, valve enable, number 1, 2, 3, 4, 5, 6. Come out of that, double check that, and then I want to check anti-north, yeah, south, yeah, feed north, feed south, link mark, outputs, link from north, anti-Legionella north, into there, link from south, into there, link from the valve north, link from south, and I don't know what the backnet points are yet because I've not brought the backnet points in, so we've still got to work out these enables. How are we enabling it? Are they just on all the time? Do we have a master switch? Let's have a look at the drawings. I know the drawings will show them being and off auto. I'll just take, that's extract fan, that's one of them there. No, that's distrats. That's number 6. So there's our auto. We energize NR1, 9 relay 1. Fresh air damper end switch. Once it's made, so once we've energized it, that opens up the fresh air damper. That automatically puts that light to open. We're in auto there. This is our active 9R2 and does the enable, but I can't see in the DesOps how these are enabled. You would have thought they would have mentioned it in the DesOps, so I need to just look through this. Let me put you on pause and I'll look through and see if I can find it. Right, I can't see in the DesOps anything that tells me about the enabling, only the control for each zone with the high and low level. I've already wrote that software to put the fans on, and the fans will be inhibited in the event of operation of a BMS fire panel. So we have zone controller enclosure to start the associated fans. So I've done that already, but I haven't added in anything to do with enabling these CRACs or enabling the thyristor units, which I presume if you enable, I think we need more information, request for more information, or be a bit more precise. Again, I haven't got a fresh air damper output, so I can't do anything with that. Call from the BMS system to open the damper and provide fresh air if the CO2 levels rise. So I'm monitoring the CO2 levels, and if they rise between these points, so above 800, switch off at 500, adjustable. But I can't see, I don't have an output. These are all my outputs. Thyristors, the D-strap fan's done, Legionella done, general extract fan done, that's done. CRAC units, flow lamp, reception alarm, and that's my speed. They're all my outputs that I've got in the panel. But that's my high and low levels, temperatures on the zones, which, let's go and bring that across again, that sheet. D-strap zone panels 1, 2 and 3, high and low, high and low. So one's for 5, 1, 2, 3, trying to see where they are. Zone panels 1, 2 and 3, they're the panels. They're the CRAC units, panels. That's our BMS control panel. They're my flushing valves. That's my extract fan. Leak avoidance valves. Outside air temperature, leak detection, drainage pump, reception alarm panel, high level and low level, which we've done then. So that must be zone 1 and 5 and 6, 1, 3 and 4 maybe. It's with that, and see, that yellow is just a basket just for the running the cables. So high low will be 5, 6, maybe 3. That high and low could be interpreted any way, that really. That's feeding through ducting to that area and that area. That's feeding ducting to that area. That's feeding ducting to that area. That's feeding ducting to that. That's feeding ducting to that. and that's to that area. So that doesn't really help me much. But I presume when we're enabling that, I've put CRAC units 1, 2, 3 and 4 for zones 1. And I only know that because of one's an open area, that's a closed area, and that's a viewing area. And those are basically the three zones. That's all the open storage area, enclosed storage area, and viewing stroke workrooms area. 3. So I know that once that's on, I want to really enable 1, 2, 3 and 4. That's on, I want to enable 5. That's on, I want to enable 6. But what I'm going to do is put the enables again for the fans, for the CRAC units. So if I duplicate that, enable CRAC, enable CRAC, yeah, I'll leave that as it is, space unit number 1, duplicate that, number 2. In fact, what I could do is move that across there, put that up there, duplicate 3, 4, duplicate 5 and 6, put that there, that there, that there, that there, that there, that there. I might as well take it from there, but I'm not. I'm going to take it. If someone overrides that, then I really want to use it from there, so I take it from there. 1, 2, 3, 4. That one is there, and that one is there. And let's just take them down to there. Just make it nice and neat. Take that one and bring it down to there. And take that and just put it in between all them. Presume I could take that zone 3 down now into there. Take that zone 2. And bring that down slightly as well. So they're my enables. So I'm in distract fans. So composite, output, output, out, 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 out. Use AX slot sheet. Enable CRAC unit number 1. Oops. 2. Control key V. Click. Control key V. 3. Control key V. 4. Control key V5, Control key V6, link mark, link from 1 to 10, link from 1, 2 to in 10 on that output, on that, yeah, output, link from 3, link from 4, link from 5, link from 6. So we still haven't got these thermistor units. Let's look at the text again. So tell me about that. Thermistors, where are you, thermistors? JB has supplied an enclosure to house a heater battery thyristor. These enclosures are also houses a voltage rescaler to convert 0 to 10 volts DC control from the CRAC unit to 0 to 8 volts DC to limit the heating output. The incoming power supply to this enclosure will be provided by others, as well as the backnet cabling from the CRAC unit to the BMS panel. Also installed hardwired cable to monitor a fault condition and a fire alarm interface to shut down the unit should a fire alarm interface at BMS panel be operated. So if they want the CRAC shut down, I think CRAC units 1, 2, 3 and 4 have a Belden network installed for the purpose of controlling these as a local group with load sharing options, which have been set up by the specialist contractor during commissioning. Have they? Alright. So with our software that we've wrote, has that output actually now included the fire alarm? Wrong one. Yes. So they will turn off anyway with the fire alarm, as well as them fans, because we've took them from the fans. So that's fine. But what do I do about the thyristor? Because we're using high and low there. So low, I presume, on high, that's the D-strap fans for the zones to move the fans around, the air around. It's also enabling those 4 units if it gets high, and then if it gets low, it doesn't move the fans around. But if it gets low, then I presume we want to put on the heaters on the CRAC units. Alright, I'm going to leave it at that, and I'm going to get requests for information, just so I don't get it too wrong. Alright, thank you for watching.